Hello and welcome back. I just thought I'd make another video to follow up on the last one that we just shot and uploaded on the building a motorized arm. It just seemed after I got it finished that it was going to be a pretty difficult challenge, both from the mechanics of making the arm actually be able to carry and drop an object to the programming. So I thought I'd spend just a few minutes with you on follow-up and tell you what I came up with. Not necessarily to tell you how to do it, but to just show one suggestion and walk you through the process of getting this challenge done. Wanted to show you here what the SteveBot ended up looking like. We started with the SteveBot build, and then you'll recognize this arm on the end as being our little hand grabber. That's the same example that I used in the last video. And what I've done is just attached the end of this piece to a little gearbox and the medium-sized motor, which will slowly open and close it. And I think I've figured out one possible solution, always keeping in mind that there's probably a million different solutions, but I just wanted to walk you through the thought process of this and on how to get it to work, and then also through some thoughts on doing the programming. I don't expect your solution to look anything like it, but I thought it'd be helpful for you to walk through the process with me and see how I came up with this and some of my solutions, and that'll give you some fuel for your new ideas. So let me move the camera down to the table and we'll get in a little bit closer and take a look at some details. Okay, so here we are, and you can see the SteveBot. I found a way to mount this whole contraption across the top using some little rounded beams, kind of stilts right there. And I hadn't used this little clear plastic gearbox in a long time. I love that little piece. And so I thought I'd try it with this one because I wanted the action of the opening and closing to go pretty slow. If I can get this in close to the camera. So you'll see that I've got in this gearbox here you can see that worm gear inside the box that drives this small gear, and that small gear is attached to the axle that moves the larger gear, and attached on one of the holes on this larger gear is this rod here that comes through and moves that scissor action right there. And let me just kind of show you. If I twist this axle down here, it's going to rotate this gear, which in turn pulls and pushes this arm up here. And that causes those to open and close. Let me grab our PVC coupler, and you can see it'll hold on and then drop when we loosen that up. You know, the biggest design consideration I had to make was figuring out a way to get that up high. This blue electrical box is really a challenge because of the height. The SteveBot is actually pretty high up off the ground, but I had to raise the arm up quite a bit, a lot more than I thought it was going to take to actually clear it when I approached it. I also had to make sure that when I opened the fingers of the claw here that it wouldn't end up touching the edge of this. So when I pulled back away, I didn't get hung up on the blue box. So that's how that goes. Let's take a look at the computer, and I'll show you some of the programming steps that I did. Okay, we'll do this kind of low tech. I'll just show the camera on the screen. Here is my program that I've written, and it starts with the medium motor. And that's the one that's connected to the claw. I've got that set to degrees, and I have that going at 100% power for 1500 degrees. I calculated how long that motor needed to go to open and close. And actually what I did was set the claw in the open position. And so this positive 1500 rotation is going to close that. So as soon as I hit this start button, I'm going to be holding the PVC in my hand, and it's going to grab it before it takes off. So it's going to grab right here. It's going to wait 3 seconds, and that's going to allow me to get out of the way. So there's no more human interaction after that. And then we have a drive forward. This is the SteveBot going forward 1100 degrees. It's going to, and that's going to get me, oops, sorry about that. And that's going to get me to right in front of the blue electrical box. When I get there, I'm going to do a negative 1500 degrees on that medium-sized motor, and that's the part that's actually going to open the claw or open the hand, and it's going to drop the coupler in there, and it'll wait 2 seconds just for any motion to stop before it backs up and returns to the start location. And that's what that negative 1100 is to get me back to the start location. So that's what the program looks like. Let's go ahead and run it and see what happens. Okay, so I've set up the blue electrical box here, and the SteveBot is located here. I've lined these up with lines on my mat here, but I think the actual challenge instructions say to do that at 3 feet, but I didn't have enough room here to do that, so I just made up my own distance. You can see that the claw on my robot is in the open position, and I'll go ahead and run the program and you can see what's going to happen. All right, and there you go. I think I'll run it again from a different angle so you can see exactly what's happening just a little bit closer. Okay, so here's the same run from a different angle. Got my blue electrical box here lined up with this line on the mat. I've got my bot here lined up with the opposite side of the mat. The claw is in the open position, and I'm going to run it. All right, so I hope that helps a little bit without giving too much away. And again, please don't think that's the only solution. That's just one of hundreds, if not thousands. I just wanted to document the process of me going through that challenge, just so I can see from the teacher perspective exactly what challenges are going to be involved. I will have to say the one thing I didn't solve was fastening this rear motor back here very well. I noticed in that last run, it moved more than I thought it was going to. And again, that's just something that's part of the continuous cycle of improvement. And so if I were to run that again, I'd probably fix that a little bit better. But who knows, you may have a completely different issue once you start your build. I wish you luck, and remember to have fun with it. And be sure to post your results from your teams. We'd love to watch video or see some pictures of builds that you came up with. Sharing that way is pretty easy, and it makes it a lot more fun for everybody involved. So good luck and have fun.